Okay, look at this question. And they said, suppose fx equals this. Identify any points of discontinuity and determine given reasons if they are removable, infinitive, or Jiang discontinuity. Okay. So when you look at this question, first you can rewrite this one as this. You can rewrite it as what? Fx equals to 1 over sine parenthesis x squared minus 4. You write like this, you can see clearly, okay? Now, sine x generally is continuous, but sine x sometimes equals 0. If sine x, if this part approaches 0, 1 over 0 will be what? Not defined. That's where the discontinuity happens. So we just, to solve this kind of question, we just say, we set sine x squared minus 4 equals 0 first, okay? So if you write this one equals 0, what value of sine, what value of here sine makes the sine equal 0? That's the time x squared minus 4 equals 0. That means if this sine 0 will be 0. Of course, sine pi also 0. You know that that's 180 degrees, also 0. 2 pi also 0. You know why? Because from the graph here, if it's sine like this, that's opposite over hypotenuse. We'll go to here, opposite over hypotenuse. But if the opposite, if the angle at what? If the angle at here, like this is 0, or here is the pi. Of course, this is 0, this is pi. This is 2 pi, 3 pi, 4 pi, 5 pi, keep going. So all of this make the, if x squared minus 4 equals all those values, the sign of those values will be equal to 0. That's the time where the discontinuity not defined. So in general, you can write like this, discontinuity happens. So this one you can write like this, make it simple. We can put it as what? X squared, you add by 4 both sides, right? So equal to x squared equals to 4. No, it's like this here. Let me see, erase this part first. So from here, if you want to continue solve it, you can put like this. This one equals to x squared minus 4. We can put it as a k pi. And the k is what? Integer. Okay? As long as k is integer, x minus k pi, if x squared minus 4 equals k pi, integer of the pi, that would be somewhere here or here. That's the time sine equals 0. And that's where the discontinuity happens, right? So you continue to solve this one, you can get what? X squared minus equals to k pi plus 4. So x will be equals to square root k pi plus 4, like this. Now, here, when we got this, so we know that's because this one equals 0 and y over 0 is infinity. So that's not belong, that's kind of the discontinuity not removable, okay? And also that continuity not jump. Discontinuity like this one here, like this one here. Discontinuity have value here. That's called what? The left limit, right limits equal. And the not equals value of the function. That's called removable. You can set up this point, go to here. That's called removable. but this is not the case. This is the case like what? For example, I drew this like this one here. For example, this is the pi. When x squared minus 4 approach the pi from left side. From left side means this side. In this side, the second quadrant here is a positive. So that's the time sine x squared minus 4 is what? Greater than 0 on this side, okay? But if this one is on this side, means what? From this side approach to pi. That's the time sine x squared minus 4 will be less than 0. And you know that this is greater than 0, of course, very close to 0. Both of them, when this approach to x squared minus 4 approach to the pi, on both sides, sine square x minus 4 will be approach to 0. Very small number, but this side is negative. This is positive. This side is positive, and this side is negative small numbers. So that means the function f(x) will be what? Like this one here. I draw it one more time on the side here. At the pi here, on the left side is a positive infinitive like this. And this one is a negative to go this. From the right side is negative like this. So this belongs to what? Infinitive. Okay? Right? So that's about the infinitive from. Okay? So let's recall what we have here. First, this is a negative exponent. We put it as a reciprocal, easier to look at. So to make the fraction discontinuity only when the denominator equals 0. So you make this one equal 0, and then you find out all the value of the x must be what? Oh, this is not that clear right down here. X must be what? Equals square root k pi plus 4. Of course, you can have both positive or negative, doesn't matter. All of them, because x squared eventually will be positive, okay? So that's no problem with that. So all those points, x equals all those values, and the k will be the integer. It's 1, 2, 3, 4, 5, 6, 7 up, and the negative 1, 2, 3 down, and 0 also included. And after identify all the points here, the function f(x) is discontinued. And then you can decide what type is that, okay? Removable like this is called removable case. In infinitive, that's this case. I just showed there, one side go to positive infinitive, one side go to negative infinitive, or vice versa is fine. That's called the infinitive discontinuity. And what's the jump discontinuity? Jump is like this. If you have function like from here, go to here, go to here, at this point here, at this point here, and the other one, they go from here, go the other way like that. So from left side approach to this number A, the limit is this value. And from the right side approach to the A, they go up to here. So that's called jump, okay? So far you have different kind of discontinuity. You have what? Removable, which is this one. That's the case. Left limit equals the right limit, just not equals the value of the function, or the value of function not defined. So you can define that one at this point equals this, make it discontinuous. That's called removable. And the infinity is just like this. From left side approach to this point, value x, the function go to infinity, positive, and on the other side approach to the same value of the value of x, and the function go to negative infinity. So that's called infinitive discontinuity. And the jump means from left side, you got one value here. From the right side approach, you got the other value. They have the gap in between. That's what jump. okay? So if you have any questions, please let me know. Thank you. Bye-bye.